Hi, everybody. Patrick Dolan. I'm a senior machine learning engineer at FlightAware. Today, I'm going to talk to you a little bit about a R&D project that we worked on involving LLMs and LangGraph and kind of some tips we found about making all that work. If you don't know anything about FlightAware, we're the largest flight tracking data platform. So we provide over 10,000 aircraft operators with services. Passengers use us, airlines use us, a lot of operators use us. We integrate data from air traffic control systems in many countries, our own network of receivers that are placed all around the globe, getting data from where airplanes are constantly, and then we're processing that data real time. We get space-based data now. There's satellites orbiting the world that are tracking planes over the ocean in places where you can't see them from the ground. And then there's data link. Aircraft are constantly talking to the ground, and they get clearances from ATC and other information, so we hook into all of those systems. And so the project we were working on was a LLM exploration project, and these were some of the goals that we had in mind. We wanted to evaluate the LLM response quality among a few different models, particularly open source models, but we looked at OpenAI as well. Understand the ecosystem for self-hosting these, for example, putting Llama 3.1 on VLLM, which is powered by Ray. Understanding some of the tools for building these applications with Ray, and finding ways to allow the LLM to interact with APIs without just giving it carte blanche access and just doing whatever it wants. And then also, can we reduce or eliminate some of the hallucinations and deviations from what we intended it to do? And so LLM safety is a big topic right now. It's really powerful what these things can do, but it's also a little dangerous if you're not careful. You may have seen headlines like this year. An airline was held by a Canadian authority liable for giving people bad advice on a chatbot. So they had to pay out this traveler that they gave wrong information to. Another one in New York City where this chatbot's just giving people false information, telling them things that are illegal. So how can we exert a little bit more control over these things instead of just letting them say whatever they want to say? And the tool we evaluated primarily was LangGraph, which is made by LangChain, or integrates with LangChain, and it works pretty well for having the LLM decide what to do. However, if you're not very cautious about it, you can give it access to a lot of things and are really big prompts, and at that point you're kind of just hoping that it does the right thing and it's not just going to hallucinate or call the API with invalid parameters or access your database and leak information. So LangGraph is nice because it kind of breaks it down into multiple components, and it does it by creating a graph with edges and conditional edges, and you can it routes through this graph, kind of deciding what to do instance by instance, and in doing so, it really breaks down a complex task into multiple agents that all have much smaller prompts, and they have one job, and so they can do something a lot better and more accurately if you don't give them too much leeway to make a mistake. And the example I'm going to go through, you can get really complicated with these graphs, and LangGraph has a lot of examples on their website of how you can do that, but by way of explanation and example, it's simpler to just talk about something little, which is a topic enforcement. So imagine you want your LLM to do something. In our case, it's searching an API for flight information, and I don't want it to talk about anything other than this. And so you can put a little guard in this graph where there's an agent that all it does is evaluate what the user wrote and ask itself, does this have to do with searching flight schedules, or does this have to do with something else? And the output is binary. It's either yes, it is on topic, or no, it's not on topic. And so what you see here is you're building this graph, essentially. You're adding nodes, and you're adding conditional edges. You can see this conditional edge. If you get a yes, it moves on to the next agent, and then it uses its tools to answer the question. If you get a no, it ends there, and it'll go back to the user with whatever response you want. And I'll show that in a little bit. And the agent state here is just whatever you want it to be. This is just a Python class that holds whatever state data you need to make decisions as the graph is progressing. So you can get really complicated with this, but we're not going to do that in this example. We just have one little string that's carrying the Boolean yes or no, is this on topic? And then you have, so this is an example of the agent's prompts. So you're telling it, this is your job. You only have one job. Evaluate this prompt. Is it on topic? Here's the context. If it is, respond with this word. If it's not, respond with this word. Don't give any other response. And that way, it's a pretty simple prompt. An LLM will follow this without, it's really uncommon for it to say anything other than these two answers. However, the cool thing about this graph is you can actually take the output of it, and if it did give you something other than a yes or no, you can actually route it back to that LLM and say, you didn't do this right, do it again, and it will do it again, and it will improve its answer. So you can create little circuits inside these graphs that will correct, self-correcting circuits in a way. And so this is a really simple example. So the agent, this is the function that gets called when you actually want to evaluate the input from the user. You're invoking the agent, you're getting the response. If it's yes, we're not going to add anything to the message stack, and the graph is going to progress. If it's any other answer, we're going to inject into the message sequence this specific response. And so what that does, as far as the user is concerned, the LLM responded, but it's actually you just injecting a message and saying, this is what I want to say when somebody is asking this LLM chatbot questions I don't want it to talk about. And then this little router is kind of the state progression. You know, if that message is in our state and we want to progress, and if it's not in the state, no. This is kind of like a fail-safe. Go back to the beginning if something went wrong. And another tool we use here are structured tools. This is really nice because I didn't want to give the LLM access to our production API or any API really, and just let it just decide how to formulate those parameters on its own. So what we've done is you can create pydantic classes, or you can do this with annotations in a function as well. But you create this class that has all the parameters that you care about, and then you have a function with those same parameters, and you create a structured tool, and you tell it, okay, this is the name of the tool, this is what it does, this is the format of the input. It has to be in this class. When you parse the user's query and you put it all together, this is what I want as your output, and I want you to pass that into this function, all these parameters. And some of these things can be optional, some of these things are required. If the required stuff isn't in the user's question, then the LLM will just say, oh, I need to know, like, what was the departure time? What time range are you looking at before I answer this question? And what will end up happening is it goes into this function call, schedule search, and what I have now is just a series of parameters. So I'm making the API call, I'm doing the programming. The LLM is not even aware there is an API or anything. It's just saying, okay, the user asked me this question, and I pulled out of that where they're coming from, where they're going, what time range they want to depart in. Do they care about what airline or a flight number? And you can get this list really long. And LLMs are really good at this, so they can fill out these parameters really easily. They make a lot fewer mistakes. And so this is like an example. So you can say, tell me what flights are going from San Francisco to Portland. The first thing it does is it says to itself, is this on topic? And it's yes. So the graph progresses, and then it says, I need to call my tool because this is related to what the user is asking. And you can have a more complicated graph here. Like, are they asking about the future? Are they asking about planes that are in flight? Are they asking about stuff that happened in the past? And you can branch off into specialized tools. And then it makes that call that I wrote with my programming that is controlled. And then it gets the response, which can be in JSON or some other format. The LLM parses that response, and then it just turns it into human speech. And you don't really have to fuss a whole lot about how that happens, and you let the LLM do what it's good at. And to give another example, if you're asking how fast does a cheetah run, is this on topic? No. And then immediately it comes back and it says that I don't know anything about that. Can I help you with, flights? And so you can control a lot of that stuff. And Langsmith is a tool that you can use if you send telemetry. It's a service where it'll intercept all the calls that the LLM made. And you can see this is more complicated here. It starts with the input. It'll show you that intermediate step where it said yes. And then you can see it'll show you what actually went into that function call. So it figured out, okay, they asked about San Francisco, they asked about Portland. I know what those airport codes are. And I said, later, tomorrow afternoon. So it knows the date and the time, and it will make that range. Now, you can be more specific. I could say between 3 and 5 tomorrow afternoon, and it will do that. So that's really nice. So kind of going in conclusion, agents follow smaller prompts better. So if you have an LLM chatbot or any other LLM-based application, and it's got this really complicated prompt, and you're running into issues where it's misbehaving on certain parts randomly, this is a good solution because it just breaks the problem down, and LLMs are a lot better at following smaller prompts. LangGraph is a good tool to use, and it's built for this purpose. And you can get really complicated workflows. You can build entire HR or booking applications on this. And there's some examples out there about that. The graph network means you have really fine control over conditions for it moving from one thing to the next. Like, for example, if it generates code, and you can have a next step after it generates code that actually validates that that code will run. And if it doesn't run, you can go back to the LLM and say, this isn't going to work, do it again, and it will do that. You can also add human in the loop, so you can have an interrupt somewhere in the graph. You can say if it's going to do something kind of potentially dangerous or modifying important data, you could go back to the user and say, here is what I'm about to do based on what you've asked me. Is my understanding correct? Do you want to execute this? And if they say yes, the graph proceeds. If they don't, it can ask, okay, well, what was wrong? What do I need to fix? And obviously the code is more manageable, as you all probably know. When you break down a system into more smaller pieces, then you can individually test those. It's easier to avoid mistakes and keep things in isolation. And so that's pretty much how that works. I was going to show you LangGraph since I have a minute here. I guess I logged myself out. Poor timing. Let's see if I can do this real quick. So this is one I did earlier. So you can see I asked what flights are from San Francisco later today. It shows you what was in this tool, what got put into the function call, and then what came back. It's all this data. And you could put this in multiple formats, but what's important is that the LLM can understand it, and then it responds like, here's a bunch of flights. And the more you could make a better response out of that function to format this better or give it a different prompt about how to format that, but that's a simple example of how that works. So yeah, that's about 15 minutes. Any questions about this? Come find me if you need questions.